Hey guys, and welcome to the last lesson of the unit here. Today we're looking at applications of the cross product and the dot product. So there are several uses. You'll notice that almost all of these are physics-based, but there are very important uses of both of these concepts. So the first one we're going to look at is work. So the work, which we write as W, that is done by a constant force of F acting on an object during a displacement of d, is given by work equals force dot product displacement. Now, it is worth noting that the W here, of course, is a scalar, not a vector, because we are taking a dot product. You can, of course, also write this as the magnitude of the force times the magnitude of the displacement times cosine of the angle between them, okay? Which is alpha in this case, okay? So you can see it over here of what this would look like if the force is going along this way and the displacement is going this way. Then that gives us our work of W, which of course I can't really draw on here because it doesn't have a direction. Okay, so that would be kind of meaningless. So it's worth mentioning too that the units for each of these. So we've already discussed force. Your units would be newtons. Okay. Your displacement, your units would be in meters, and work, your units will be in joules. Okay, it's a measure of energy. Okay, there we go. All right, so let's take a look at an example of how this would work. Okay, so we've got a box being pulled a horizontal distance of 100 meters by a force of 500 newtons applied at an angle of 30 degrees to the horizontal line. So we're going to calculate the amount of work done, which is fairly straightforward for this one, because we can just say work equals, and I'm just going to use this version of the formula. Okay, we just multiply the magnitudes by the angle because that's what it gave me, and so I get 500 times 100 times cosine of 30, which is just equal to, it actually works out to 25,000 root 3, but because in this context, writing things as exact numbers, whenever you're doing these application questions, that's kind of not really helpful. So we'll actually write this as a decimal, we'll round it to 43.3, and that would be in kilojoules. I know I said it'd be in joules earlier, but I don't want to write such a big number, okay? So there you go. So let's take a look at another one. Example 2, an object with a weight of 50 newtons is moved in a vertical plane along the path ABCA as presented next to the figure where AB equals 6, excuse me, AC equals 3 meters. We're going to find the work done by the force of gravity. Okay. So what we're going to do here from A to B, so let's take a look at the picture. Okay, we're looking, whoops, keep in mind it is the force of gravity we're interested in here. Okay, so my force vector, okay, is going to be 0, negative 50. Okay. Okay, hold on a second, sorry. Pause this. Okay, so let's just recap why that is there. So we've got our force, which is right here, and you can see it's going down 50 newtons there. So the negative is because it's going in that down direction. Okay, and it's not going side to side at all. Our displacement here, Okay, our displacement, now this is from A to B. I'll write that here. Well, if you can read that. Let me try. Let's do something. Let's A to B. There we go. All right, so this is my displacement from A to B, and that would be 6, 0. Okay, which is because we are going, yeah, well, it says that right here, actually. So it's side to side. Okay, so there's an X component, there is no Y component. So when we go to find the work here, so work is just equal to the force, and it's the dot product with the displacement. So it's going to be 0 times 6, because we multiply those X components, plus, and then I've got negative 50 times 0. Okay. And so, obviously both those equal 0, so it actually is 0 joules. Okay, so the work done by the force of gravity here is nothing. Okay. So, and that makes sense because the force of gravity is pulling it down, so the side to side, there isn't going to be any energy. Okay. The B to C we'll do here. So this force is still the same. Okay. That's going to be from 0 to negative 50. Oh, and I should put this. I didn't put my vector signs over these two. I'm sure you all noticed that. There we go. And then we'll go displacement. And this time, because we're going from B to C, this is going to be negative 6 and 3. Okay? So this time when I go to do work, it's going to be same thing. Force, dot product, distance. Okay, but that's going to give me 0 times negative 6 plus negative 50 times 3, which just equals negative 150. Okay, there we go. So I'm actually going to get you guys to do C and D yourselves. So feel free to pause the video and I'll tell you the answers, but I want you to try those yourself. So what you should get is for this one 150, and for this one you should get 0. Okay. All right. So let's take a look at torque. Okay. So the torque, or the rotational or turning effect about the point A, is created by the force F acting on an object located at the point B, and is given by, and so we use tau as the symbol there. It's another Greek letter. It's a little hard to draw sometimes, but that's going to be created by the vector from A to B times the force. Okay, and this is a cross product. Okay. You'll also notice that that could be written as, and is often better to be written as R cross F, where R is obviously the radius there. Okay? To find the, if we were looking for the magnitude of tau, or the torque, it's going to be R, or the magnitude of R, times the magnitude of F, and then sine alpha, where alpha is the angle created there. Okay. All right, so let's see how that works, because that's a little confusing without an application. So we've got a wrench here, okay, and the wrench is 30 centimeters long. It's used to loosen a bolt by applying a force of 20 newtons. Okay, and it's all labeled in there, you can see. So, first of all, we're going to find the magnitude of the torque. So, first of all, let's look at what our radius here is, or let's just find the magnitude of the radius anyway. So the radius, okay, which is from A to B, is going to be the 30 centimeters. Okay, that's just the length of the displacement between A and B. Okay. And then we've got F And I'm just, you'll notice I'm not using the vector symbols here, and that's just because I'm just doing the magnitudes here. So this would be 20 newtons. Okay. Alpha then, which is the angle created between F and R, is going to be, well, it's 180 minus the 30 degrees. So it's going to be 150 degrees. Okay, and you can see right there, I've already labeled it. Okay, so there we go. There's all the information we need. Now we can just use our formula. So we'll say the magnitude of tau is equal to, and again, I'm just going to not bother using the vector symbols so that I can show that it's just magnitudes. Okay, and so we've got 0.3. Now you might think, well, I had 30 centimeters a minute ago, but you need to be consistent, so you should be using meters here, because that's when you're working with newtons and joules, if you're not actually changing anything, it should be in meters, not in centimeters. And so then we'll multiply that by 20. Okay, and then sine of 150. Okay, and this will just give us 3. Now our units for torque are actually Newton meters, so it's just Nm. Okay, which is not a unit you'll use very often, but there you have it. Okay, and that's it. All right, so let's jump over to the next one. Let's do some area questions. So there's two area questions we're going to look at. We're going to look at parallelogram and triangles. So the first one, parallelogram. So first of all, you can see this is the parallelogram created by the vectors A and B. If we're trying to find the area created by that parallelogram, it's actually fairly simple. It's just going to be the magnitude of the cross product. Okay, so we take the cross product of A and B, we find the magnitude. Now sometimes, depending on how you're given it, or how you're given these vectors, it may be easier to use this version where we take the magnitude of A, magnitude of B, and sine alpha, where alpha is the angle between them. Okay? Simple enough. So let's do example 4 here. So I've given you components. So this is where it's going to be easiest if we start by just finding the cross product. So before we look at the magnitude of the cross product, we're going to actually find the cross product. Okay? And so just off to the side here, well, I'm going to write it here. So just off to the side, I'm going to write out, let's see, so we had -1. Remember, you start with y, and we have z, and then we have x, and then we end with y. Okay? So that is, yeah, just make sure I got that right. And then we have 1, 2, 0, 1. Okay? And then we do that times that times that, and that times that. So we will get, let's see, so we'll get, whoops, we get -2 for x, and we'll get -2 for y, and we'll get 1 for z. And there we go. So there's our cross product. Okay? So now we just have to find the magnitude of that. So the area is just the magnitude of A cross B. Okay? Which is just going to be the square root of -2 squared plus -2 squared plus 1 squared. Okay? Which is the square root of 9. Which, of course, works out very well, because that's going to be 3. And what are our units here? Does it give us units? Oh, it didn't give us units. So I guess we're just done then. That's it. It's just 3. All right, so our area is 3. Okay. So if we wanted to do the same thing, but we're looking at the triangle here. Okay. it's going to be the exact same, except that it is only half of the area. And if you actually look at the shapes, that makes perfect sense. You're just cutting it in half. Okay? So the area equals 1/2 of the magnitude A cross B. Okay? Or alternatively, we can say 1/2 A times B sine alpha. Okay, whoops, oh, didn't need that. There we go. Okay. So again, you just use whichever makes more sense given what you have, okay? So to begin with, you'll notice that I'm not giving you vectors this time, and you do have to be very careful when you're reading these questions because it's an easy mistake to make, and that's why I try to use the vector symbols over the points that I give, but often, I mean almost no books actually do that, which is unfortunate because they should, but there you have it. So really pay attention to whether you're looking at points or vectors. So before we do anything, we have to actually create the vectors. Okay, so we have to find out what is vector AB. Okay, and remember, you're just doing, you're just subtracting the B coordinate from, or sorry, the A coordinate from the B coordinate. So we'll have, let's see, so we'll have -1 minus 0 for our x. We'll have, let's see, where's B? I lost it. 0 minus 1. And then for z, we will have 2 minus 2. Okay? So we're left with -1, -1, 0. Okay, so that's all there is to it. Okay, and we do the same thing for AC, which will leave us with 1, -3, -2. Okay, so you're just subtracting the coordinates there. All right, so from there, we're now going to find AB cross AC. Okay. And you're going to do the same thing. You're going to write out the coordinates starting with y. I'm going to skip over that, and I would like you actually to try it and make sure that you get the right answer, because it is important that you understand and can get the right answer. But what you should be left with is 2, -2, 4. Okay, and there we go. Okay, so all that's left then is we need to find, we need to say, well, the area is 1/2 of 2, or sorry, yeah, of the magnitude 2, -2, 4. So it's 1/2 times the square root of 2 squared plus -2 squared plus 4 squared, which leaves us with root 6. Okay, and I'm just going to leave it as root 6. Depending on the context, you may want to give a decimal. It depends. I mean, if I've just given you coordinates like this, and I've just, like, it's not really an it's an application in the sense that you're finding area, but I haven't told you contextually what this triangle is or anything, you can just leave it as root 6 is probably the best. But if I've actually, given you a scenario surrounding it, you're probably going to want to actually just give me a rounded decimal in that case. Okay? All right, so the last one is the volume of a parallelepiped, if that's how you say it, which I have no idea if that's how you pronounce it. I've only ever seen this word written. But anyway, what we're going to do is the volume is going to be the magnitude of C, and we take the dot product of C with the cross product of A and B. Okay? Now, interestingly enough, you could also do it as A, because you're looking at that and you're thinking, well, what if I get the wrong one for A and the wrong one for B? It actually doesn't matter, because it's the same as A dot C. Oh, or no, it does have to be B and C, so does it? I'm not sure. the same as that, and it's the same as B dot C cross A. There you go. So those three, all the same, doesn't make a difference. Just do one of them, okay? Let's see. Yeah, so let's try it. So we're gonna find the volume of this guy here. So what I'm going to do, first of all, I'm going to write it just off to the side because I'm going to have to do a cross product, and so before I can actually start using this formula. So I'm going to write out the version of the formula that I'm going to use, okay? And then I'm just going to go back and figure out the answer for the cross product that I'm going to need. So the volume here, I'm going to use A dot B cross C. Okay, so that's what I'm going to use, okay? So before I do anything, I'm actually going to go back and say, well, I need to find out what B cross C equals. Okay. So, and you just, again, I want you to actually attempt it using the system that we've been using, but I'm just going to tell you the answer right now. So I do think it's worth you pausing the video, attempting the cross product, and make sure that you get this answer. But you should be left with 2 minus 4, 2. That is the cross product. So we go back to our formula here, and we want, so what's A? A is 0, 1, -3. So I want that dot, and of course I've got this in absolute value. That's just going to, it is absolute value here is what I'm doing. Like, so where I've drawn these absolute value signs, it doesn't actually mean magnitude in this case. It does mean absolute value, and that's because if we get a negative answer, that's fine because we're just going to drop the negative, because of course you can't have a negative volume. That doesn't make any sense, okay? And so then it's dot, and then this was the cross product that we found, -4 and +2. Okay, so we take the dot product, and in fact, when we take the dot product of this one, it's we get, let's see, it's 0, 2. Whoops. Oh no, hold on. Let's do this. So it's sorry, not 0, 2. It's 0 times 2. 0 times 2 plus 1 times -4 plus -3 times 2, okay, which gives us -10. And as I say, that doesn't make any sense. So we drop the negative and we just get 10. Okay, and that's it. All right, so that's it for this time. Until next time, go Sabres.